Hello, everyone. Welcome to another MoMath event with MathPickle. And yeah, this is puzzle time. So you've arrived at the right place. Today, we have a very special change of scene. Instead of me, we have my friend and excellent math educator, Steve Heller, and he's going to be explaining and playing with you some beautiful stuff. So Steve, I'm going to stop sharing. And why don't you say a little bit about yourself, Steve, and something, why you like pickles so much? That's my common question to all of the kids is, why do you like pickles so much?
If you do like pickles, because of course it's not just a I like pickles club.
I don't like full sour pickles, but I do like half sour pickles. Is that okay, guys? Can you give me a thumbs up if that's okay?
That's fine. As long as it's pickles, it's pickles.
Yesterday at my Sunday school, we had a pickle party.
Oh, excellent.
Wow.
With pickles and pickled mango and seltzer lemonade.
Sounds like everybody should have been doing math.
Eh,
A pickle party, to me, that means math.
Maybe.
So I'm very happy to be here. I'm glad that Gord invited me. You might recognize me because I've attended some of the sessions last month. And I teach a lot of kids, what I call math explorations. We try to figure things out ourselves, just like in puzzle time. We try to discover things, and that's what we're going to do today. And I really want everybody to cooperate. In other words, don't dominate the discussion, but you can say what you have to say, and you might be able to build off of what somebody else says, and we can all understand and move forward together. So that's what I want everybody to think about. And we're going to do an activity I call cookie party. What do you think?
if it's a puzzle about cookies, then
It's sort of
yep,
it's
kind
sort
of.
of
Yes,
So-
cookie party. Yes.
so who likes cookies? Thumbs up if you like cookies.
I like chocolate chip cookies. I don't like raisin cookies because I don't like raisins.
Does anybody like pickled cookies?
I don't know if that's a thing.
I've never had a pickle cookie. Is that a thing?
I don't know. I just wondered if anybody might have tried it.
I bet it would taste gross.
All right, so let's get going. A cookie party. Could someone volunteer to read the first couple of paragraphs?
I would like to.
Go ahead.
Okay, so do I read the entire thing or just some of it?
You can read the whole thing.
Okay. 5 friends join a cookie party, each wearing a different color. All sit at a round table. There was one cookie for each friend. One way to give out cookies is friend after friend around the table. Another way is to give a cookie to every other friend. Either way, everyone gets a cookie and is happy. Click the blue buttons to trace the cookies paths for hop counts.
1 and 2. 1 and 2 hop
1 and
count.
2.
So
I was just confused.
at the beginning of this activity, for at least the first half, I'm going to control the screen. But if things go well, I'm going to let you all have your own screens and proceed and try all the things yourself. Okay?
Okay, be careful about that though, because
So-
everyone can be chaos.
Should I press, which button should I press? Hold up 1 or 2 fingers. I see a bunch of 1 fingers. Okay. So this is what I call one hopping. We start at the red one and we go around person by person, friend by friend, and everybody gets a cookie. Does that make sense? That's
Yeah.
one hopping. What do you think 2 hopping is? Any ideas?
I don't know.
This is 2 hopping. Now that you've seen it, who can describe two hopping for me?
I'm gonna let someone else do it.
All right, I'll show you again. We started red, we go to green, then
We go to
yellow,
yellow, and then blue,
purple,
and then
back to red.
purple.
So why is that two hopping? Amelia?
Because it's going from it's skipping one.
Right. We think of it as counting to two. From red, we count 1, 2, green, we count 1, 2, and stuff like that. All right. So does everybody get the basic idea? One hopping and two hopping?
Yep.
We usually go in the direction of the arrows. All right. So this one, Aria, would you read this first paragraph?
With 6 friends, we start. With 6 friends, we start the cookies at red, and the cookie hop 1 time clockwise and trace the thick red line into blue. And then trace the blue, and then trace the line from blue to green. One hop past blue and green gets a cookie.
So when you get your hands on this activity, the idea is you learn to draw, and you draw one hop. What should I connect next for one hopping? You can speak up. Go ahead, Aria.
So I think you should go from yellow to orange and orange to red.
Right. This is what I call one hopping. And in this activity, we'll get to draw a bunch of stuff. And we'll also let you draw some. Gord, do we have Zoom annotations or not?
Sometimes we have annotations.
Let's
I can
be ready.
turn them on and off.
All right, let's be ready to go.
Okay,
Now-
I will be ready.
All right. Now at the beginning, we had 5 friends. Now we have 6 friends. And we're going to try two hopping. Okay, everybody ready to two hop? That's interesting. Huh. Let's
3
do
people didn't get any.
Well,
Two
6
hopping
is
and three-
divisible by 2.
Well, 4 people didn't get any.
So what's the problem? I think we heard the problem that some people didn't get any cookies.
6 is divisible by 2.
Yes, it is.
Once we go into a loop, we'll end up at the same place. If we make it not divisible by 2, then it'll have 1 left over, which means that it'll go into a new loop.
So what would you recommend we do?
Add 1 or take away 1 person.
Is this Taco Cat speaking?
Yes.
So we can't take away a friend because then they'll be very sad.
Well, then we have to choose a number that 6 is not divisible by. Let's say.
Oh, so we need a different hop count, you're saying?
The number can't be 4 either.
So let's keep looking. So some hop counts, some friends don't get cookies. If we want to keep the same hop count, one way to do it is to just start from a new person next time. And we can serve more rounds until everybody gets a cookie. So this time I have a red round of cookies and a green round of cookies.
Nice. Everyone's happy.
And everyone's happy. And this is the 3 hopping. So we can make it work even with any kind of hopping. We just start again. Does that make sense?
Yep.
All right. Now, do rounds ever give 2 cookies to one person? Especially people who haven't spoken yet. Does anybody have an idea about that? If we have 1 round and we keep hop counting the same way, will anybody ever get 2 cookies?
I don't think so if you end when you start.
So do we end where we start?
Well, on a round we do end where we start.
Okay. So why?
Erica,
Why do you think we always end where we start? Oscar?
Because eventually everyone will have everyone that the count can get if we'll have a cookie, and then it has to go back to the start.
Right. So eventually we'll run out of people that don't have cookies, and we have to give either we have to get to the start point or give someone or everybody will have a cookie. Let's keep going. Wait a minute. We were going clockwise. What happens if we go backwards? So when we trace around, which means draw the lines, when you go backwards, if we trace the line backwards with one hop counting by one, that's what this is hop counting by one. Is this a new shape or a shape we've seen before?
It's a shape we've seen before.
So what about hop count 2? Does that give us a new shape?
I don't think so.
So can I get a volunteer to do hop count 2?
So I'm going to yell out volunteers here. Angie, you're up. Hop count 2. Does that produce a new shape, or have we already seen that shape?
I'm pretty sure we've already seen it.
Yeah. So hop count 1 does not produce a new shape. Hop count 2 does not produce a shape. Does any hop count to the left produce a new shape? We didn't get the hop counting to the right.
Emmy and Emerson.
What's the question?
Do any hop counts going the opposite direction produce new shapes?
I think so.
Which hop count do you think will produce a new shape in this with 6 friends?
Most preferably 3.
All right, so I'll clear this out, and I'll do hop count 3. Have we seen this shape before? Yeah, we've seen this shape before. So that one's not a new shape. So hop count 3 is no new shapes. What about hop count 4? Is that going to be a new shape?
Hank.
I don't think so.
Yeah. So so let's check. We can check. No new shapes by reversing. Can anybody tell me why we never get a new shape when we go backwards?
It's a loop.
Yeah.
So Taco Cat, what do you mean by it's a loop?
Well, it's an unending chain until we run out of cookies, and it'll follow a pattern. If we had infinite friends, then there wouldn't be any shapes. And if we don't have infinite friends and enough cookies, then we'll have the same shape.
Just because we have a loop, does that mean when we try to go backwards, we'll follow the same loop?
Well, in this situation, it seems so, but maybe there's a situation with an odd number that it'll be the same shape, but it might be flipped horizontally or vertically.
So we may have some symmetry going on here. Did anybody notice? We'll come back to that. That's very nice observations. So one of the things I really like is we can name shapes. So we have 7 friends now, and we have hop count of 2. So that would look like this. And I want you guys to think of and write in Zoom annotation what you would name this shape. What do you think? What should we call this shape?
I have an idea.
Go ahead.
I would call it star-ish. Not star, but star-ish.
We have star suggested, starish.
I'd call it Confusagon.
That's also good.
I'd say 7-pointed star.
And by the way, it's time for a poll.
Oh, good call, Sully.
So I guess it's poll time. 7-pointed star was Oscar's suggestion. So what if I change colors now? And I have purple and I do a
Weird star.
hop count of 3.
Okay, I want people to think about that as I'm doing the poll.
Rotational symmetry.
So there's the poll, and you guys think about the 7-pointed star.
Oh, and by the way, just because they're on the call, don't put in the thing 10 plus unless you actually have 10 plus 10 or 10 plus people in your house.
All right.
Yeah, it's not the number of people watching on Zoom. It's the number of people watching from your house. Yeah,
Yeah.
thanks.
I always like to clarify.
100% have answered. All right. So what does everybody see this purple figure I drew? What should we call that one?
Butagon, 7-pointed star, number 2, Junior.
Epic star.
Superstar.
Do we like this star better than the other one?
Yeah.
I think
that's
this
good.
one should be called a 7-pointed star
This
with
one
a
should be
small
called the
inside.
double star
Why a double star?
because it kind of like has a star in the middle and then a star on the end.
Well,
Yeah.
We have 2 different stars. We have the orange star and the purple star.
Well,
Well, the purple star kind of has one star on the like from the middle, and then like one big star and one small star.
Like-
Let's see what happens when we do a hop count of 4. What color should we use?
use any color.
How
Maybe
about
orange.
Blue.
Orange or blue.
Blue sounds good.
Nice.
Orange might be close to this one here.
Oh, yeah,
So-
true.
1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4.
Huh.
1, 2, 3, 4.
Looks
Hey,
like Belgium.
what's going on?
It looks
Something-
the exact same.
4 is 2 times 2, so the 2 hop and the 4 hop.
What?
I think it's
This is
at 3 and
crazy.
4. 3 plus
So,
4 makes
I heard
7.
something about 2 and 4 and 3 and 4. But in any case, have we seen this? Have we seen this before?
Yes.
So we can. I think was it similar to 2 or to 3?
It was similar to 3.
So we can take
Because
all the
it's the-
names, all the shape names we have here, and just copy them all down here. Oh, that's interesting. Notice that we had 7 friends in this. The friends are always written at the bottom. What happens if we? Who would like to do read a paragraph, please?
I mean, if anyone wants to, that's fine, but I can do it.
No, somebody who hasn't participated. Aria, you've done a lot. And Oscar, would you like to read a paragraph?
Yes, I'll just read the first one. 2 different hop counts are twins if they trace the same shape. With 8 friends, 1 hopping and 7 hopping both trace an octagon. So 1 and 7 are twins. If you find any more twins, note the twins' hop counts on the table.
So you notice I already put 7 as the twin of 1, and 1 is the twin of 7. Does
I
anybody
just
have any?
realized something. We had 3 and 4 were the same. 3 plus 4 was 7. And now we have 7 and 1 are the same, and 7 plus 1 is 8.
So hold on to that thought, and let's let other people think about it too. Can anybody else besides Taco Cat make a prediction for some of these hop counts, or do we need to draw them? Does anybody want to predict who's the twin of 2 or 3 or 4? Aria?
I think that 6 is the twin of 2, 5 is the twin of 3.
Hold on. Don't tell us everything. So 6 is the twin of 2,
Yeah.
and 2 is the twin of 6. And then you snuck out one more. 5 was the twin of 3.
3.
3 is the twin of 5. And does 4 have a twin?
4, I think, is the twin of 8.
So 4 would be twin of 8, and 8 would be twin of 4. Can I have a thumbs up if you agree? Thumbs down if you disagree. What do you think? Are these twins all good for you? Gord is half agreeing, half.
I
Oscar
think
says
8
thumbs
might.
down.
I think 4 isn't with 8.
So let's check the answers.
I agree with Oscar.
8 is not correct. I know I don't check 4 because it's not clear what's going on. I probably should, but you're right. 4 is not the twin of 8.
I think I know what 8 is the twin of.
What is that, Oscar?
I think it's like 0.
What would it
It
be?
stays at the same point. It doesn't even make a shape.
Exactly. That's the comment up here. Taco Cat, would you read this paragraph?
When 8 hopping, tracing a path of cookies does not trace any lines, just a dot for each round of cookies, a dot shape.
And so that's why I wrote dots down here. So if we have 0 hop count, then we'd also have dots. So this is what we call search for twins. Now I have predicting twins. Now we have 9 friends, and only people who did not predict anything last screen should speak up. Who can predict what the twins are for any number from 0 through 9? Can anybody new make any predictions? Can we call on anybody that might have an idea? Amelia, do you have an idea?
No.
Aiden has a hand up.
Oh, Aiden, would you like to share your idea? You're muted.
I just wanted to say, I didn't hear what we're doing right now.
We're handing out cookies to friends around a table, and we're jumping the same distance each time. We call that a hop count.
Okay, so I would think 8 would pair with 9.
So you think 8 would pair with 9, and 9 would pair with 8. Okay, why do you think that?
Because they're both next to each other.
That's interesting. They are both next to each other. Taco Cat, would you like to give us one idea?
2 and 7.
2 and 7. Thank you. Who else? Angie, would you want to give an idea for who are some
Oopsies,
twins?
I forgot to lower my hand.
That's okay.
No. Why?
Because you're done talking. You have to mute it.
What about you, Aria? Can you tell us one more pair of twins?
So I think that 3 no. So I think that 9 and 0 pair up.
9 and 0. That's interesting. Why do you think that?
Because it kind of like is happening with like the other one.
Yeah.
So now I think that 8 and 1 would pair up.
All right. Don't tell us all of the answers, though. So does anybody see a pattern? 0 pairs with
looks-
9.
Like the numbers are going down.
Oscar, do you want to predict the next pair?
Then it would be 6, 5, 4, and so on.
So this is an interesting pattern. Let's say
I have a
let's say-
theory.
Taco, go ahead.
The Sir Taco of Cat's theorem at the moment is that the twin numbers are, both of them are the sum. The sum is the number of dots.
So the twin plus the hop count equals friends, let's say. Is that right?
So yeah, both the twins, the sum of the twins is equal to the number of dots.
All right, and we can write that as a function that the twin of some hop count. Let's just write the twin. How do we predict the twin if we have a hop count and a number of friends? Oh, wait a minute.
The number of dots minus some number.
So friends minus hop count. So somebody cleverly drew a part of a rainbow. Would you, anybody who wants can draw just one band of the rainbow connecting the twins?
That was Gord.
You can use the resume annotations. Thanks, Oscar. And Arya is coming in with the red. And Seth, haven't heard much from Seth. So this is a pattern that we see a lot in math. We see this in the twins, and we sometimes see this in factor pairs when we give the factors of a number. Well, let's go on. Can we erase everything, please? Now, this one is a little tricky. A single round of cookies sometimes traces a simple shape, no crossed lines, and sometimes traces a star, which has crossed lines. With 12 friends, can you predict 12 friends now? Can you predict which counts will trace stars with just one round, and which one will trace just polygons? Anybody want to suggest? Somebody says one hop traces a star. Is that X to be intended to be a check or no check?
Check. No check.
No check. Okay. So we think one does not, well, one just goes around. So that's not a star. So 2 hops, we think 2 hops traces a star. Let's try that. 2 hops, 2 hops.
Yeah. Exactly what I got, I guess.
But that's not a star. That's not a star.
Yeah.
That's not, doesn't have any crossed lines. So
Yeah.
so 2 hops does not have any crossed lines. What about 3 hops? Or can we predict it before we do it? Someone put an X, but I want to know why. Why do we think this will not have any crossed lines? Any ideas? So somebody checked 5. A lot of X's in 5.
I checked 5.
Why do you think 5 will produce a star, Oscar?
Well, I think that it won't trace a star every round. If the amount of hops is 1 less than the amount of friends, 1, 0, the amount of friends, or it has a factor in common, and that isn't 1 with the amount of friends.
So if it has a factor, so we have this end condition, 0 and 1. Let's not worry about those too much. And then you say the other ones have to have a common factor with what? With the number of friends, I think you said.
Yes, with the number of friends.
Wow, that looks like a crazy star.
Huh. That does look like a crazy star. I think that was a pretty good theory. I'm going to jump ahead, and I'm going to hand out class tokens as soon as I show you. There's one more thing that you guys can figure out on your own if you want, that if the number of rounds it takes to fill it up. So here we have 10 friends, And how many rounds will it take if I have a hop count of 2? Solomon says 2. Why? Oscar was close, pretty much right on the last screen. This one's a little tougher. So I'll let you guys think about this on your own.
There's an even number of dots, so it'll always come back to the beginning and take 2 tries.
Arya, do you have a thought?
Yeah, I think that the number of rounds is the number of the hop count.
What about 8? Will that have 8 rounds?
I don't know.
Anybody have an idea whether 8 will have 8 rounds? Ah, Taco Cat's reminding us of something about the rainbow. So you guys can figure this out. I'm gonna just push on. This is a slide where you get to practice everything we learned, where the twins are, where the one round has stars, number of rounds, and you guys can do that on your own in a minute. And this is how you plan a party. On this slide, you can change the number of cookies. You can make 12 cookies, 113 cookies, any number you want.
The
And
one
then
with the you can
Go
talk.
ahead.
The one that I had, like, a lot of the friends looked really pretty.
So like a really big number.
Yeah, that looked really pretty.
Somebody wants me to try 212. Yeah, but we can't see the friends. But
Yeah.
it's really
480.
it's really hard. It's really hard to do hop counting on this. But what if we have a robot to do it for us? This is quick serve robot, and anybody who
180,000.
friends, let's try it. 180,000. Oh, it doesn't go that big. How about
Yeah.
100? How about 1,800 friends?
That looks. It's broken.
What about
Will the Sir
600?
Taco of Cats theorem be disproven by this robot? I think not.
So let's trace one around with 600.
gonna
Oh,
be-
look, 1,800 friends and 600 hop count. We look at that. What about
It gave us
hop count of 240? We get
Make a small number like 50.
friends, you mean?
No, in the hop count. It'll look beautiful. Small numbers. The smaller the number, the beautiful.
We can't even escape the band.
Well, then bigger.
So, or we can make this a little smaller.
100.
Oh,
So
there's a perfect.
I want to show you one more thing that we might do. Like, what if we want to have stuff that crosses the middle? What do we have to do to the hop count?
600. I mean 900.
900. That's directly across the middle, and I can show all the rounds.
Oh, it's so
Beauty.
weird.
It's
also
beautiful.
It's
So
so
we're-
pretty.
What if I do eight? What if we do
Wow.
800,
Hang on.
and
let
then
me
we
s-
show all the rounds?
Oh, gee.
All
Whoa.
right, now I'm going to give out the code, and you guys can play with it, filling in the table, or try to find really cool patterns. If someone finds a cool pattern, you can share it with everybody, and then someone else can try it. So I'm going to put in the chat a code, and when you get onto the Desmos website, you don't have to log in. You can proceed without logging in. All right.
All right.
So I'm putting it in the chat now. And anybody who wants can log in. They can use the robot. You can try to fill out the predict all the things chart. But if you find a really cool pattern,
I don't see it.
It's not in the chat.
You
Are
might
you sure you
have.
posted
oh,
it?
that's
You
because
probably did it to a private
I
a
did.
direct
You
link.
need to do it.
Sorry.
Send it to everyone.
Yeah, not to just.
Now
like,
tell me if
Gord.
it worked. Did it work this time?
Yep, there it is.
I see it.
So you don't have to log on. And when it asks you for your name, give a funny nickname. Don't use your regular name when you log on usually. Okay?
How do you do it? You just continue without signing in.
Yes, continue without signing in.
Junior is like,
I'm gonna do my internet name.
And I want people to try to, if they figure out how to predict the number of loops. We didn't do that. You can comment on that. Or if you find a really cool pattern or any other observation that you can play with. And by the way, I challenge you to break the robot.
Oh yeah, let's do it.
Let's go.
By the way, I'm Super K Cat 72 with a K for cat.
All right.
Of
I see that we have a lot of people are going through the slides and poking around. You can fill out the slide. This slide, I think these slides will be available for 2 weeks. So you can come back and check it out, make cool patterns. Has anybody gotten to the last slide for the robo drawing?
I just went to the last slide.
Yeah, I'm on the last slide.
Me too.
One.
My thing's pretty cool.
So tell me a cool pattern and tell me why you think it's a cool pattern. Notice you can have it draw one loop. You can have it trace one loop slowly or draw it quickly. You can have it trace all the loops or draw them all quickly. And if you have big enough numbers, even drawing them quickly makes a cool pattern.
I broke the robot.
Well, how did you break the robot?
I broke the robot.
Number 9. I just put my finger down on the number 9 and I waited. And there's a little error sign that popped up. And now it does not.
So big numbers can break the robot. So
Yeah.
what's another way to break the robot besides big numbers?
It's really laggy if you put in the hop count 1,482. And then if you choose the number of friends, it's 9,872. The robot gets really laggy.
I broke the robot.
How did you break the robot?
I just put like a whole bunch of zeros and then like a whole bunch of ones, and then it eventually goes away, and then it's like
Right, it does
hop
get laggy.
count, and then
Wait,
just
what's the hop
it's
count
broken.
to break the robot?
So did anybody make any cool patterns?
I haven't yet. Let me actually do that.
To break the robot.
Avocado cream.
I'm getting a lot of lag.
Did you scrape my screen for your background?
Yeah.
I kind of broke the robot.
To
The
make
cookies are now in the middle of space. I just put in a decimal.
I got really
with the hop
laggy
count.
for a second.
So Taco Cat, you did a decimal?
Yes, I put like 0.11111.
Amelia, what's your idea?
I broke the robot. That's laggy.
Yeah, use decimals.
Let's
It's
take
fun to use
turns.
decimals. It gets really weird.
0.3 is really cool. You can actually see how it's just in the middle of nowhere.
Whoa!
Amelia, what's your idea?
You're right. That's cool.
Pattern.
I
Sorry?
broke it again.
What happens if you put
Especially
like a
the first
negative
one to
number?
break the
Everybody-
robot. Yeah.
Try
Let's-
putting in a negative number. Oh, you should try putting in a negative number. It's
So
I
everybody
also-
calm down a little bit. Amelia, what is your idea?
I found a cool pattern.
if you put in a negative number and then you put in a number in the first. Oh wait.
So hold on a
oh wait,
second.
negative numbers.
Amelia has the floor. Amelia, what is your cool pattern?
If hop count is 55 and the number of friends is 99, and you do show all rounds, it's pretty cool.
So I'm going to try that right now.
That is really cool.
You can also.
I think I made a circle. If you put in negative
can-
13 for the hop count and then 250 for the friends.
Okay.
So let me ask you a question. Does negative hop count produce any new patterns?
Nope.
Why not?
I think that negative hop count is like going counterclockwise.
Who agrees with Oscar about this counterclockwise theory for
I
negative
agree.
hop counts? I agree too. Did anybody notice?
Taco Cat approves of this message.
So let me ask a different question. Did anybody notice any symmetry?
I just got something that was very unsymmetrical.
I found something extremely cool.
If you put
Besides my dad's phone.
Hold on. Who? I think is Solomon speaking.
Yeah, if you put in 13 for the hop count and then 25 for the friends, it looks really cool.
Well, everybody might want to try that for a minute.
Oh,
I just found
wow.
something. If you put in the number of friends as the square root of 5 and the hop count 2, then it's a really unfair game.
So that's a new way to break it with irrational numbers. I like it.
Yeah, irrational numbers and decimals break it.
I also found out a cool way to break and not to like break the border. If you put like kind of breaks like the whole situation. Like if you put like 10 and then 0.5, there's like an extra dot that shouldn't be there. And it's really cool.
You're using decimals or fractions, right?
Right.
What happened?
I just found something that was so unsymmetrical. Like it just looks like there's lines going in random directions, and then there's this little colorful line at one point. That's not supposed to be there.
What is it?
0.1 for the hop count and 2 friends. It's kind of weird.
Do what?
0.1 for the hop count, 2 friends.
They drop their cookies.
Oh my.
All right. I'm gonna shut down the sharing.
Decimals and irrational is at the moment.
They're holding cookies.
So we're gonna end in with about 2-3 more minutes. Did anybody have any ideas besides cool patterns that thought might be interesting to share?
Yeah. If you put 0.67 for the hop count and then choose 2 friends, I think I broke it.
Oh, what about this one?
Oh boy.
Try 4 for the number of friends and try 0.0001 for the hop count. It's kind of weird.
If you put 2 to the power of 7 to the power of 8, it doesn't do anything. It just has a screen and a small like orange symbol that you can't do this.
Amelia, would you like to share?
I did the orange symbol earlier when I was.
You 11 friends and 0.30 hop count. The cookies are like outside of the circles.
What again? I want to try that. What again?
0.30 for the hop count and then 11 friends.
Wait, do 123 friends and then 0.000001 for the hop count? It's kind of broken.
Oh boy.
So I have to ask you guys, do you like the emojis and the cookies?
Yeah.
Yeah.
Because some of my colleagues said too many emojis. And I said, I like more emojis. What do you think?
I actually think it was a bit too many emojis, in my opinion.
If you put in 123 as the friend count and then 0.5
More
as the hop count, it's really
emojis.
broken because only the right half is
More
working. The rest is breaking.
Emerson.
If you do 0.513.
Okay, hold on, Emerson. You want to share?
If you try 12 for the amount of friends and 0.0001 for the hop count, it's like the cookies and the circles are actually in the same place. There's like a circle around each cookie.
Wow. I also found a way to make a cool pattern thing with all the things.
So if I want to know what happens in a certain friend and I want to hop by hop count H, which friend do I go to? I add H. I just want to ask you a question. What would happen if instead of adding H, we multiplied by H? What do you think would happen?
When you do a
Oh,
big
I just found
even
something.
number as the amount of friends, and do that even number divided it by 2 plus 1 as the
I think
Alright.
I
then
think I broke
that'll
it.
make
So
it like
if you
all
have
filled.
101 for the number of friends, well, just put 101 for the number of friends, and then if you put anything for the count, either that I'm glitching somehow or it's not. Oh wait, no. Okay.
I think I've broken it.
All right. I want to thank everybody for playing and breaking my software. And
I found a really beautiful one, highly beautiful. If you put in 101 as the number of friends and 5 to the 7th, which is 78,125 as the hop count, it's a really beautiful pattern. Really
Wait,
beautiful.
what was it?
We'll hold on to that.
101 in the friends and 5 to the 7th in the hop count.
Put for the hop count, try putting in 1, 2, 4, 2, 3, 4, 5, and then for the number of friends, put in 101.
What would you call that pattern?
In my pattern, or
The last one that somebody said 1, 2, 4, 2, 3, 4, 5 over 101.
I just got a really beautiful, almost weave, like a pattern that kind of weaves around itself. The lines.
Isn't math art pretty?
Yeah.
So we're going to say the official goodbye now, everybody.
Okay.
But we can stay on for anyone who wants to stay on and to keep on talking with Steve for another few minutes. Can you stay, Steve, for a little bit longer?
I would be glad to.
I have my own
I would like to talk
slide
with the
if
puzzles.
you guys want to join, if anybody wants to join the slide for doing stuff.
But yeah.
Say that again, Seth.
Somebody said they have a slide that people are welcome to join.
It was Taco Cat who said it.
How do I join?
Okay.
Whoa.
Taco Cat, you did a direct message, not to everyone.
Oh, you have to enable doing it to everyone,
Yeah,
I think.
Okay, everyone is now enabled. You can talk.
Oh my goodness.
Everyone. Yeah, go ahead, Taco Cat. Okay.
I need access.
What happens if the hop count is bigger than the number of friends? Did anybody think of that?
Yeah, so actually if you make the hop count really, really, really big, and then if you have the number of friends be reasonably small, sometimes it glitches a lot and like you get these really weird shapes that aren't symmetrical at all.
So let's say we don't go hog wild in big numbers. We just have, 24 friends and hop count of 635. Does that give us anything different than low hop counts?
I found a really cool image.
Go ahead, Solomon.
Okay, for the hop count, go 3,211. And choose the number of friends is 143 and hit trace.
Trace one round or trace all rounds?
Trace all. It's truly a beautiful sight.
3211 and number of friends is 143.
143.
And trace all rounds?
Yep.
I like and it has different colors. So it actually has different rounds.
And if you keep going, it looks so beautiful at the end.
If you put 6 with a bunch of zeros for the hop count, and you put and if you put 101 for the number of friends, if you just keep putting zeros, it's gonna get weirder and weirder.
Okay. Can I say something that broke it?
Sure.
if you put 0.1 for both of them, there's one green dot and there's absolutely 0 cookies anywhere.
Does anybody have any suggestions how I can make this more of a fun activity?
Add like a chat or something, maybe.
I'm sorry, Taco Cat?
Add maybe like a chat box in there so you can share your ideas without interrupting other people.
Okay,
Oh, so
how do
you
you
can, that's possible
Okay,
when I give out
cool.
tokens for a whole class, but I didn't want to do that today because it's very hard to maintain on a large Zoom class. But you guys can play around with this activity for the next couple weeks if you want.
Yeah, this is really fun. It's really fun to break the quick serve
Computers
robot.
are fun to break.
Yep. Except
Why
pretty
is
good to
it
your
why is it the
computer.
kids like to break things?
I can't write in your Google Doc.
Okay, do you want me to request
boy, I
access?
broke it.
No access is required anymore. And to answer to Steve, the reason that kids like to break stuff is that it's much easier to destroy than to create. And they feel like
True.
they've done something, and doing something negative is easier than doing something positive.
Thanks for sharing that, Taco Cat. I find that quite interesting.
I can't.
Philosophy.
We can't do stuff on the slide. Do you want me to
Okay.
request access? Or should I not request access? Or
We just need
Oh
to.
yeah, sure. I thought I enabled it. Yeah, you guys can request access.
I broke it again.
Yes, breaking things.
Yeah. Because for the hop count, I put 0.5. And for the number of friends, I put 10. And then there's like cookies out of the border and it's like half filled up. It's really
0.5
weird.
and 10.
So do you guys want
0.5
to
for hop
you
count
guys
and
want to
10 for friends.
do you guys want to have a secret peek at another activity?
There's actually a very weird one.
Okay,
Steve, why don't we just invite Steve back? Because I can tell you, the next peak, is it the one I'm thinking of, Steve?
Of course.
Yeah. So I think that one's really fun. Now I'm happy if you want to have a sneak peek at it, but we could also just trust Steve to produce something great. What would you like? You want a sneak peek?
Sure.
Okay. Let's do that sneak peek, Steve.
So this time
wow.
instead of adding a number, the hopping count, we're multiplying by a number. Okay. And what do you think happens when I have increased the number of dots?
Oh wow, that looks so fun.
Taco Cat. So to make it so everyone can edit, you gotta go to the share button.
Yeah, click the new link. I
did.
This,
it still doesn't allow you to share.
this is sometimes called string art because all these shapes are made with straight lines.
It's under the one where everyone can edit. Oh, everyone can join. If you go to that, it'll say everyone can join, can view, and then you click that, and then you change it to edit, and then everyone can edit.
Another way that mathematicians
Or you can change it
this,
to comment, and then everyone can comment.
They call this ruled diagrams. A rule is a straight line, and when you have ruled surfaces, you have straight lines on them. And it turns out that if you make nice patterns with straight lines, it looks like you have curves. Did anybody find any more cool patterns that aren't breaking it?
Yeah. I did. For the hop count, put 0.91.
That's breaking. That's not, that's a fraction. I'll try it anyway.
And for the number of friends, put 25. The cookies are on top of the people.
Oh.
That's funny.
0.0. Oh, wow.
And also, if people want to ask about other puzzle time puzzles from the past, you're welcome to do that now also.
Wow. This is fun to break.
Oh,
It's fun to see what weird and wacky things you can create with this.
So I'm going to say that that is a good place to end it for today for all of the kids. And we will have Steve back again, because I think that snippet at the end, that is some of the most beautiful math that I've ever seen. So I would love to invite Steve back to play with that.
Okay, well, I'm gonna leave now because you said
Yep. Bye, kids.
bye.
Bye bye.
Let's
Bye.
stay here.
I like your scream avocado cream while she left.
You guys can now edit the slides if anybody wants. This will work on all days for all puzzles.
Like all the puzzles and MathPickle.
Bye bye.